Okay, guys, welcome to lesson 2. And from what you see, we see geometric, sequence and series. Before we get into this geometric, yesterday, let's do a quick recap. Yesterday, we looked at arithmetic sequence, right from grade 7, 8, 9, 10 to 11. But we added the grade 12 part to it. We learned some shortcuts yesterday. And from what I saw yesterday was the first time some of us are learning those shortcuts. And you need all of that for grade 12. Okay, we would apply quite a number of those. Then we came to the grade 12 part, which was the series part of the work. And we said we have a formula which we learned how to prove. I hope you guys practice and please learn to prove that formula. We applied it. I had about 2 questions that I gave you. This morning, before we go to our geometric, we're going to do quite a couple of questions. 1, 2, 3, 4, 5, 6. All right, we're going to do about 6 questions just to emphasize the understanding from yesterday. Okay, if you look at this, I'm not sure we had this as homework, but if you look at this, let's start from here this morning and we do it together. Some questions I'll keep quiet for you to try to work through, but I think this was yesterday. In an arithmetic sequence, the third term is negative 4. Please, I want you to learn one thing. Change the English into maths. It will always assist you. In an arithmetic, so the first thing is I know the type of pattern. In an arithmetic sequence, the third term is negative 4. I'm quickly going to write T3 is negative 4. And the 7th is negative 20. I quickly do that. How many terms will add up to? Keyword. How many terms will add? Interesting. The word add there simply tells me it is sum. Means sum. And we know it is Sn. Look at the first thing I'm going to do. Let's write the formula for Sn. N over 2, 2a, because the examiner said sum. Okay, if I look at the formula, I'm going to ask myself, what are the things I need? What is it that I am looking for? It says how many terms. So basically, I'm looking for n. Will add up to negative 140. Oh, so I know that the sum of those numbers should be equal to negative 140. But how many numbers should I add together to get that? Now, if I look at the formula, I see that I'm going to have a problem. I don't have A. I don't have D. This I have. Where will I get my A and my D from? We go back to grade 11. T3 is negative 4. Okay, what is T3 by the way? A plus 2D. This should be instant. You should know this instantly. Negative 4. All right, this is my T3. What about my T7? A plus 6D. That we should know how we got that. And I told you, once I have 2 equations like this, I can just subtract. A minus A would be 0. 2D minus 6D would be negative 4D. And negative 4 minus 20, that is positive 20, minus 4 would give me 16. So what is D? D is negative 4. Now I can get A. A plus 2 into negative 4 equals to negative 4. Now that will give us a negative 8. If we move it over, it becomes positive 8 and A is 4. Check. I think I have what I need. I think I have everything that I need. Now, back to the formula. Sn equals to n over 2 2a plus n minus 1d. Negative 140 I do not know n, no problem. That's what I'm looking for. But I know my a. Plus, what is my n? Unknown. No problem. But I know my d, -4. The rest is algebra. Let's try to take it step by step. -140 n over 2. What will this give us? That will give us 8. Now, can we do that? -4n plus 4. -1/4. Now, quickly, guys, I could do something here. I could multiply this quickly to make life very easy for us. Some of us that don't like fractions, but it will be the same anyway. Now, what is 8 plus 4? That is 12. So I have 12 minus 4n. But I have to multiply this in. So minus 140. What is 12 divided by 2? That will be 6n, right? Minus 4 divided by 2 is 2. All right, what we have? -2n squared. Interesting. We come back to trinomial. Okay, let's move everything over. 2n squared minus 6n minus 140 equals to 0. Okay, let's divide. Let's see if we can find factors. This is what? 70. All right, I already see factors. Do you see factors with me as well? I think I'm seeing what? A 10 and a 7. But I want -3. So, that. Yes, 7 minus 10, -3. So, n minus 10 equals to 0 or n plus 7. All right, n equals to 10 or n. A number of terms cannot be negative. We cannot be counting number of negative terms. So, our n is 10. Look at the number of marks. I'm only looking up now. 8 marks. Are you okay with this step-by-step approach? Beautiful 8 marks. Beautiful. So you would see what I did was I first looked at the formula. What am I looking for? And that guided me step by step. Interesting 8 marks. Let me know, thumbs up, thumbs down. Give you a moment. I know you'll be writing. But while you're writing, let me know, are we okay with what I did? Are we okay with what I did here? If there's any question, please let me know. The first thing is to read the question to a point of understanding. Once that is accomplished, then you can handle the rest of the story. Let me know if we can then move forward as well. Can I move forward? Next question. Somebody can screenshot this and just drop it on the group in case we move forward and others come in and want to copy, or I see a lot of people still just joining in now, just waking up. Somebody please just send a picture of this. Also to let people know that the class is already on. Someone quickly, there's so many of us. Kutwano, Tando, Waruna, Musadi, Musa, Kazeka, so many of us. One person can just quickly take a picture. Thank you, Tejo. Beautiful. All right. So the picture is there if you need to go back and write. Now let's move on. The sum of n terms of a sequence of numbers. This was given yesterday. Now we know that Sn is given as n over 2, 5n plus 9. So we are told that the formula has been condensed. Calculate the sum to 23 terms of the sequence. Number 1. How many numbers? 23. 3. So my n becomes 23. So we have 23 over 2, 5 multiplied by 23 plus 9. Put that in a calculator, and we are done with that question. We are done with that. What would that give us? If you have an answer, please also share with me. $14.26. Confirmed? Thank you, Teko. 14.26. Beautiful. All right. Thank you for confirming, Kozeka. And number 2, we did this yesterday. Calculate the 23rd term. Examiner is looking for T23. We developed a formula yesterday that says, we said this is not on the formula page. Please don't write it like this. It's different. Please. The -1 is on the term. Please, it's a subscript at the bottom. Mind how we write. So T23 will be S. See, my M is 23. 23 minus 1. 22. And from the first question, I already have my S23. Let's find S22. What will it be? 22 over 2, 5, 22 plus 9. What will this give us? That's 11. 5 times 22 plus 9. 1309. Therefore, T23 will be 1426 minus 1309. 1426 minus 1309. 117. Let me know if we are on the same page. So these are the questions you are going to be coming across in the course of your matric year when it comes to number patterns. Are we on the same page, everybody? Please, let's ask and let's respond. 1 mark there, 1 mark there. You'll get 1 mark there. You'll get 1 mark for subtracting, and you get 1 mark for your answer. Is there any question? Can we move forward? Can we move forward? I need all the responses I can get, as many responses, just to make sure that you are not left behind. If we could get another picture on the group, let's just send all of this question and solution. It will be nice. Question and the solution, it will be nice. Because sometimes we don't have time to write all the questions, and it might be a very good point of revision. You have the question and the solution. Anybody with a picture quickly? Time, guys, time. Thank you very much, Tando. So let's keep that as a practice. Oh, no, sorry. What did I do? Okay, look at this one. The first 3 terms of an arithmetic sequence are -5, 2, and 9. Remember what I said? I want to do a few questions on arithmetic before we start flying. Show that the sum of the first n terms can be given by. All right, it's an arithmetic. What do you notice about this arithmetic? -5, 2, and 9. What's the difference? It's actually 7. 2 minus minus 5. Okay, so that means the next two terms, we should add 7. All right, if we add 7, what are we going to get? 16. If we add 7, 23. So 3.1.1, my answers are 16. Show that the sum, 3.1.2, let's see if we're going to get that. It's an arithmetic. What is Sn? N over 2, 2a. Okay, so you would see I'll be working with the formula. I do not know n. Okay. Do I know the first term? Negative 5. We do not know n. But what's our difference? Our difference is 7. Now let's simplify. N over 2, negative 10, plus 7n minus 7. What are we getting? N over 2, which is the same thing as half n, minus 17 plus 7n. Perfect, which is the same thing as 7n minus 17. Oh, done. And you can see these are level 1 questions. We expect everyone to get them right. Are we good? All right, remember to send the solution. Thank you very much. Oh, Tando, you are in the flow now. That's it. That's good. So that, guys, when you want to revise again, you can always go back. The question is right there. You can rework the solution out and make sure you understand. All right. Beautiful, beautiful, beautiful. Okay, let's see. Can we move on? We still have a couple of questions to look at. Ooh, I love this one. I love this one. And the reason I brought this is to let us know that maths can just be math. Look at this. Consider the sequence. Negative 11. 2 sine, oh my Lord, 3x, 15. Somebody's already breathing so hard. Why are we having trigonometry again? Welcome to maths, guys. All along you've been doing maths lit. Welcome to maths. I promise you. Okay. Now, the question says determine the value of x in the interval between 0 and 90 degrees for which the sequence will be arithmetic. I want to train you guys on reading. If it is arithmetic, then I should have a common difference. That's how we think in maths. What can I interpret? Oh, it means that my difference, T2 minus T1, should be the same as T3 minus. You see, the questions may be different, the tones may be different, but the approach remains the same. So what is T2? 2 sine 3x minus negative 11, 15 minus 2 sine 3x. Let's move the negative 2 over. It becomes positive 2. 4 sine 3x equals to. Now remember, this one is a positive 11. If it goes over that side, it becomes a negative 11. And 15 minus 11 would give us what? 4. Divide both sides. Sine 3x, therefore, is 1. Oh, we go back to grade 10. Arcsine of 1. I'm sure we know that. And that should be 90 degrees. Do you see? The principle just remains the same. The principle remains the same. I hope it makes sense to you. So learn, don't be scared. Maths will always want to give you that first scare. Don't allow it. Don't allow yourself to be bamboozled by what the question is saying. Take time, get a pencil, underline, ask yourself, what is it that I can interpret? Once I interpret, oh, great. What can I then infer and do? And that's how we work out maths. If you allow yourself to be intimidated, I tell you 1 + 1 will intimidate you. Okay, thank you again, Tando. Can we move on? You see, we're still doing arithmetic. I want us to have as many questions as possible, which exposes us. All right. Ooh. Let me come back to this one. Let's do this one. Oh, it's just one more. I wanted to see what you can do first. Do you want to try this for me? Let me give you 5 minutes or 6. I want you to try. What's going to be your interpretation? Try for me. Did we manage, everybody? Did you manage to figure something out? Thumbs up, thumbs down, quickly. Just give me a response. Don't be shy. Even if you have to give me a thumbs down, no one is going to see you, don't worry. All right, I see tears all over the place. Tears. Aww. Okay, you guys are giving me thumbs down, so let's read. Given the sequence 7, 1, 7, 3, 7. Oh, wait. 7, 1, 7, 3, 5. I noticed something. 7, 1, 7. Oh, I'm noticing. I'm noticing something. What do you notice? 7, 7. And the other one is a 1, a 3, and a 5, which gives me a difference of 2. Oh, so the 7 becomes constant, and the one that is in between is an arithmetic. Learn to observe. What is the 17th term going to be? Let's see. Do you notice the 17 is an odd number? Look, this is T1. This is T2. This is T3. T4. T5. T6. What do you think T7 would be? It would be 7. And if I continue, T9, T11. 17 is an odd number, so all odd numbers will have a term of 7. I'm done with my first one. T17 will be 7. Did that make sense to you? Okay, I see a thumbs down. Please unmute yourself quickly. I see a thumbs down, Kutlwano. Please unmute yourself. Let's be fast. Let's go forth and back. There was somebody else that gave me a thumbs down. When you give me a thumbs down, I want us to go forth and back, talk together as if we are in the same physical space. I got 2 thumbs down. Anyone who wants me to go through with them, please unmute yourself and talk.
Sir.
Yes, Kutlwano, how are you?
Since you said 17 is an odd number, sir, I thought what you did.
Sorry?
Since you said 17 is an odd number and it's equal to 7, I thought see what you did, sir.
You don't see what I did?
I see what you did, sir.
Oh, okay. Now you're okay.
Yes.
So we're saying all odd terms are 7. All right, great. I don't know who else had a hand saying thumbs down, but that's just simply it. All the odd numbers are the same. T1, T3, T5, T7. Even if the examiner had come and asked you for T101, it will still be 7. Because it's a pattern that we see. All right. Determine the sum of the sequence from T9 up to T13. From T9. Okay, so the examiner is creating a whole new ball game. T9, T10, T11, all right, T12, including T13. Wait, odd numbers. This is 7, this is 7, this is 7. I don't know why they're saying this is 4 marks. Determine the sum. Determine the sum of the sequence. Oh, I think it's a repeated word. Determine the sum of the sequence from T9. So T9 to T13. This one is so easy. I'm sure we can get T10. What will your T10 be? Okay, if you want to use mathematical methods, we can find Tn. You can even do it manually if you see. Because look, this is 5, T6, T7. What is T8 going to be? 1, 3, 5, 7. All right. What is T10? I'm using my arithmetic now. 1, 3, 5, 7. What will this be? 9, And then the addition of 2. 9 plus 2 would give us what? 11. Oh, so I can then say my sum, this one doesn't even need maths, but I don't want us to do things manually. We need to learn to do it mathematically. 7 plus 7 plus 7 is 21. 21 plus 11 is 40. 40 plus 9 is 49. Did that make sense to you? Did that make sense to you? But we don't want to do things manually. I need us to learn how to walk through. Okay, we've got to mute this person here. All right. We cannot learn to do things manually. What if the examiner says from T9 to T88? I can't be doing da. It's going to be wrong for us. So we need to learn how to use systems to walk through. Systems. So let's let's work out a system to get this done. So I'm going to repeat the whole process again, but right now, not manually. I'm going to work with a system. Okay. All right. So check this. Now, let's find, remember, Sn will be what? N over 2, 2a plus n minus 1d. You've got to be careful on this one. So watch the system. The first thing I know is that for the arithmetic, my Tn will be 2n minus 1. Is that making sense? We've been through that. Now, I already know that T9, T11, and T13 are all going to be equal to 7. All right, I'm coming there. Now, but what else do I have? What is T10? 2, 10, minus 1. This is 19. I'm doing this so that if we have lots of numbers, we create a system. Okay, so my T10 becomes 19. All right, now look at what I'm going to do. Sn will be equal to, how many odd terms are there? 3. And each of them is equal to that. Plus, I hope you're seeing what I'm doing. This is to help us in case I have to do T9 up to T50. Then I'll come here. I notice that there are only 2 arithmetics here. Right? Only 2 arithmetics. So the number of arithmetic numbers are 2. A is the first one. The first arithmetic, my first term, 19, plus n is 2. And what is your common difference on the arithmetic? 2. Let's see if we are going to get the same answer. And then if you are lost, I'll be able to guide you. 21 plus, that is 1 into bracket. 2 times 19 is 38. You can type everything in. I'm just like this. I work with a calculator. 2 minus 1 is 1 times 2 plus 2 there. Well, we're having 61. Did we make a mistake on the other additions? Let's see, 10 and 12. Wait, 61. Hold on. Let me check on something. Did we make T9, 10, 11, 12, 13. Let's see something here. This is 21. Yes, talk to me.
Sir, I just wanted to go back to the number line which you extended. Maybe that's where the mistake is.
Okay, 1 second. Sorry, 1 second. I don't even think, sorry, I'll come back to you. Just want to, 9 plus 11 is 20. This one is actually 41, not 61. 41. Okay, all right. Okay, let's come back here. Yes. Talk to me now. I'm here. Oh,
So like at the number line, it's 7, 1, 7, 3, 7, 5,
Yes.
7, then 7, then it should be 7 again, then 9.
okay. I think I see where my error is. Check. On the number line, this 10 is wrong. It's not T10. On the arithmetic, that's where the error is. All right, guys, if I look at my arithmetic, term 1, term 2, term 3, right? Please go back to my entire number line. Term 1, term 2, term 3, term 4. Term 5 of the arithmetic is T10 of the entire sequence. So that's where I made that error. So on the arithmetic, it's supposed to be T5, not T10. Did you see that? That was the mistake. On the arithmetic, 10 minus 1, 9. Makes sense. Did that make sense to you? That was an error there. Let me know if I cleared the error. Okay, it was an oversight. It was a terrible oversight there. So 21 plus 1 there. I have 18 plus 1. 2 minus 1 is 1. No, this should be 2. 1 times 2 is 2. 41. So we cannot keep doing things manually. We have to learn a system of doing things. Did that make sense to you? Sorry about that. I completely omitted that I have a 7777 in between. We're good. We're good. All right. Please send a picture. You need to send first this one. Like I said, we don't want to do things manually. We don't want to keep doing manual things. It's childish. Manual sometimes would work, but sometimes it's a complete waste of time. If the numbers are very big, it's a complete waste of time. And then we have this one. And you'll understand where the 5 came from. Thank you, Tando. You're doing a great job. Okay. I want to give you a chance to look at this. It's 3 marks, so it shouldn't be difficult. 5 minutes, because I want you to think carefully. 5 minutes. Hi guys, did you manage? Did we manage to get something out of this? Okay, I'm going to help you to see what this examiner is actually saying. And arithmetic is series, so it's an addition. It's given such that I see they added all the odd ones to give me 3029. And they added all the even ones to give me 2014. Okay. Determine the common difference. It's quite a challenge. But let's approach it somehow. Let's see. Okay, so if I change all the T's to A's, would that help me? So I'm going to think this through with you, okay? If I work with the first one, it's A plus 2D. All right? I hope that makes sense. A plus 4D, you know where I'm getting that from. A plus, okay, we're not going to write the whole thing, 6D. And that continues A plus 2012D. I'm just trying to interpret 3029. Are you okay with that first line? Let me know. So with math, you first need to think, what is it that I can write down? Now, the problem here is this. How many terms are here? How many terms would you say are here? All right, so the entire thing, hold on. The entire thing was from T1 plus T2 plus T3 up to 2014. How many numbers are here together? All right, there are 2014 terms, right? Because we're basically counting 1, 2, 3, 4, 5. Now we divided it into odd and even numbers. Okay, this is not going to be very easy with what I'm thinking in my head, because I have 2D, 4D, 6D. It's not going to be very easy to add. Are you with me? Let's think of something different. I'm going to try to work around eliminating, but don't forget that there are 1007 terms in each. 1007 odd and 1007 what? Even. I hope that makes sense. That will give me 2014. Okay. Let's try something. What if we subtract these equations? Okay. What is T2? A plus D. What is T4? A plus 3D. Please listen to me. What is T6? And all of this will just give you exposure. A plus 5D. Now that continues. And this is A plus 20. Oh, by the way, don't write yet. And this is 6050. All right. What about the next one? What is T1? T1 is A. What is T3? A plus 2D. Okay. I'm seeing something. T4. A plus 4D. Okay. And if we continue, what's the last one? A plus 2012D. Oh, this is interesting. 3029. May I ask, before we continue, are you okay with my interpretation? Are you all okay? I don't want us to come back, so I want to carry you along. I don't want us to finish that somebody's giving me a thumbs down. Are you okay with the first one and the second one? Lovely. Let us subtract equation 1 and equation 2. So I'm going to come here and put a minus. And you've seen me do that whenever we have two equations and we're solving simultaneously. Okay, what do you notice? Do you notice that a, I'm going to quickly write it out. It's going to, the first one will be a plus a minus a, which leaves me with d. Is that fine with you? Okay, let's go through the second one. A plus 3d minus a plus 2d. What do you notice? A plus 3d minus a minus 2d. 3d minus 2d. Oh, beautiful. D. Okay. It's getting interesting. Did that make sense? It's becoming very interesting, right? What do you notice? Do you notice the third one will also give me d? Why? It is 5d minus 4d, because a minus a would give me 0. Interesting. So already we have a pattern. It means the d's are going to continue. Even the last one is giving me a d. A minus a, 2013 minus, oh, beautiful. Now, what is 6050 minus 3029? That would be 1, no, yep. That would be 1, 4, that would be 2, that would be 0, and that would be 3. Is that correct? Yep. And we have already established that we have 1,007 of those. 1,007 D's will be equal to 3021. What is D? What is 3021 divided? Oh, this examiner is cruel, but interesting. 3. Beautiful, beautiful maths. Beautiful maths. Did that make sense? Guys, the more you do questions, the more exposed. I don't even remember. I don't have this. I have not done this question before. I just use a booklet that has a lot of questions. I use 3 of them, all from KZN. You've seen me open those documents, so I just love the questions. All right, thank you very much. I think I just got a picture. Thank you, Tando. Before we go to geometric this morning, yes, treasure, the A just cancels out. All right, before we go to geometric this morning, I have another question. I'm just quickly going to write it off my head. I just remembered it now, and I can't really find where it is. Then we'll go to geometric. Consider, it's also a common question. Consider 5 plus 10 plus 15 Okay. Question 1. What is the value of the above series? Number 2. What is the sum of all natural numbers from 1 to 120 that are not divisible by 5? This is a very, very interesting question. Please, let's write. I'll give you, I'm not going to ask you to do it. Okay. We're going to do sigma. Don't worry, Tili. We're going to do, no, it's not Tili, it's Tili. Tilizi. All right. We're going to do sigma. I think sigma we'll have to do tomorrow. I changed the order. Okay. From now, I'm going to go to geometric. Then we combine the sigma of arithmetic and geometric. We do it together. Okay, so don't worry, I got you. All right, please, let's write this quickly. Okay, can we walk through now? Now, consider 5 plus 10 plus 15. What do you notice? All of these numbers are divisible by 5. Do we agree? They are all multiples of 5. So, let's deal with the first part. Let's deal with the first part. Okay, so 5 plus 10 plus 15 plus 120. Interesting. Calculate the value. It means we need to add. This is why, guys, I said we cannot do things manually. I can now start getting my calculator 5 plus 10 plus 15. Now, I don't have time in an exam. Since it's an arithmetic, oh, beautiful, we can simply use our SN formula. 2a plus n minus 1d, or I prefer this one because I know A, I know L. It's simpler. The problem is, what is n? I don't know n. So let's create a pattern to get n. 5, 10, 15. Okay, difference is 5. So what is my Tn? 5n, because 5 minus 5 would give us a 0. Oh, beautiful, beautiful. So what do we then know? If 120 equals to 5n, what is n? 120 divided by that would give us what? 24, I think. 24. So there are 24 terms here. Oh, therefore, I can say S24 will be 24 over 2. I like this one because I know my first and my last one. A plus L. So once I know the first and the last, that's a lot simpler to use. But both of them would give you the same answer anyway, so don't be stressed about it. Just get my calculator. It is 12 times 125. 1,500. Are we okay with that? Yes, Valerie, the last term. But you can also use that first one, you'll get the same answer. Okay, I want to write it down, just follow my calculator. N is 24 over 2, open bracket, 2, open bracket, my A is 5, plus, there are 24 terms, so 24 minus 1, close bracket, and the difference is 5. Make sure you close all the brackets, 1,500. But for me, once I see I know my first and my last, I just like to work with that formula. So practice both of them. They are quite important. Now, the second one is the challenge in this. What is the sum of all natural numbers? Okay. Oh, Treasure, you were asking what does L represent? Okay, thank you. I see. Valerie was just thank you, Valerie. I missed that question. You're so sweet. Thank you. What is the sum of all natural numbers from 1 to 120 that are not divisible? Wait. Number one, the examiner says sum of all natural numbers. It means from 1 that are not divisible. We need to add 1 plus 2 plus 3 plus 4. 5 is divisible, so I'm going to say 6 plus 7 plus 8 plus 9. I cannot add 10 plus 11 plus 12 plus 13 plus 14. I'm going to jump. Okay, do you notice this is so complex? And this is not an arithmetic anymore. Why is it not an arithmetic? At a particular point, I'm having a problem. My difference is 2 there. All along, fine. 1, 1, 1, 1. Then it starts again, 1, 1, 1. And then it jumps to 2 again with 2. I know somebody's thinking, okay, let me do this. Then I'll do this one. Then I'll do this one. And I'll do this one. it's going to be a problem. Systems. In order for you to see what I'm going to do, I want to do something very small with you. Don't write yet. What is 1 plus 2 plus 3 plus 4 plus 5? 1 plus 2 is 3. 3 plus 3 is 6. Okay, that's 15. I want to show you what I'm going to do on a big scale. So I'm doing it on a very small scale now. 1 to 5. Those are natural numbers, right? Let us extract numbers that are even numbers. 2 and 4. What is 2 plus 4? 6. These are even numbers. What about odd numbers? 1 plus 3 plus 5. What would that be? 9. But what do you notice? If I add the 6 and the 9, what am I getting? I don't know if you guys got what I just did there. That if I separate them, the individual totals can add up to give me the total. Did I lose someone there? That if these are even numbers, right? I'm just using this to show you what I'm going to do. Numbers that are divisible by 2. Okay? 2 and 4 would give me 6. What about numbers that are not divisible? 1, 3, and 5. Okay. 1, 3, and 5. Not divisible. But if I add the divisible and not divisible, it should give me my total. I'm going to use that system. I'll write the formula for you. It's not a formula per se. S, sum of numbers that are divisible plus sum of numbers that are not divisible should be equal to S total. Sum of numbers that are divisible plus sum of numbers that are not divisible within a frame. Oh, that was why the first question was giving us numbers that are divisible. Do you notice that the numbers that are divisible here, 5 was missing. Next one, 10 was missing. 15. Those numbers are already here. Oh, so we have them, 1,500. We already have this. What are we looking for? We are looking for sum of numbers that are not divisible. Or sometimes they use the word multiples. Can I get total? Total will be all inclusive of 1 to 120, including 5s, multiples of 5. Including the multiples of 5. Okay, so let's walk through. Now, if I say 1 to 120, then I can use Sn n over 2 a plus l. There are 120 terms from 120. I'm going to teach you how to count. Counting is not very easy, but I'll teach you how to count. What is a? The first term is 1. The last one is 120. Oh, I'm using this now because it's all inclusive, both divisible and not divisible. 121 times 60, 7,260. Oh, so S divisible, 1,500. Plus sum of not divisible, therefore, is 7,260. Can we conclude? Sum of not divisible, therefore, will be 720 minus 1,500. 12 minus 5 will be what? 7. So this should be 5,760. Am I correct there? All right, let me know if you got what I just explained. I was just talking to myself. Let's see, please feel free to let me know. So I first did it in a small scale to allow you see what's going on. Then I took it over to a big scale. So that's what math will do. Once the principle works on a small scale, it works on a big scale as well. This is a common question. You're going to come across this. And also this is to expand on how we think. So many more arithmetic questions that we may find. So now you need to be able to search for questions and walk through. Okay. Let's go to the business of the day today. So this was why I delayed the sigma notation. I wanted more practice. Which is very, very important. Never, ever run away from practice. Yes, Bonolo, please ask. Bonolo.
Oh, hi, sir.
Hi.
Sir, so I just wanted to ask, will the numbers on the number question that has been given to us, will it always not appear on the when doing the calculations, like when you were looking for if the, let's say the range is from, like as we did right now, put the example from 1 to 120, so I can see that 5 is missing, 10 and 15 is missing. So is it always going to be like that, or this now is just an example?
Kind of. If it follows this tone, it's going to be like that. All right.
Okay.
So you'd find maybe things that are not divisible by 7. It means the multiples of 7 are missing.
Okay.
Things that are not divisible by 3, it means the multiples of 3 are missing. Okay, so it's a kind of a trend. Good question. All right. Okay, my good learners. Let me do something before we move on. How do you count? Counting. Just want to show you something quickly. We'll still come back to this. Counting n. Should we do this? No. I'll do this when I do sigma notation. I'll come back to this when I do sigma notation. All right. I'll do that when I do sigma notation. Let's move quickly to this morning's job. Geometric sequence. Geometric sequence. Wherever we stop, we don't want to force too many content. We're just going to go gradually and gradually and gradually. Now, geometric sequence. What are the properties of a geometric sequence? Let's start from the general formula. And then we would use that to walk around. Tn is A multiplied by R to the power of n minus 1. Okay, let's define. Where A is the first term, that is T1 is A. So you would notice even under arithmetic, T1 is also A. So that's not going to change. What is R? That's the question. R is a constant ratio, not just a ratio. And R can be calculated as Tn over Tn minus 1. We are dividing here. That is, let me put that easier. We can find R by saying T2 over T1, which is the same thing as T3 over T2, T4 over T3, which is the same thing as T100 over T99. It is a ratio. And obviously n is the number of terms. All right, let's create an example. Let's create an example. Let me wait for you to finish writing. Let me put a number here. Okay, so let's look at this together. I'm sure you are done writing now. So if you look at this, what do you notice? Now you will try to first check if it's an arithmetic. But it's not going to work out for you. That one I can promise you that. Because it's no longer a constant difference. If it was a constant difference, then I'll just subtract. But you will notice now that it's not a constant difference. Okay? So you would notice that, let's check if it's a ratio. What is my ratio? 4 divided by 2, and that's 2. Okay? I can also check 8 divided by 4. That's 2. I can also check 16 divided by 8. So that confirms it to be a geometric. Beautiful. What is my Tn going to be? A r to the power n minus 1. What is my A? My A is 2. What is my ratio? 2 n minus 1. Let's check if it works. If I'm looking for T4, will it work? AR4 minus 1, which is AR to the power 3. What is my A? 2. What is my R? 2 to the power 3. That is 8 times 2, 16. So it works. So here quickly, please, let me just quickly do something here. You must know that T1, we're going to be fast here. T2 is AR. T3 is AR squared. T4 is AR to the power 3. So it's always one less. T99 is AR98. I want us to quickly sort that out. T500 is AR499. Are we okay with that, please? It is n minus 1, one less. Let me know if that makes sense to you, please. That's a very important, I almost forgot that, but we needed to sort that out quickly. Now, if I were to ask you, therefore, how many terms are in this sequence? We just do exactly what we're doing under geometric. We do exact same story of what we were doing under geometric. What will it be? Or under arithmetic, rather. I now know my formula. Tn is 2 multiplied by 2n minus 1. Now, 3, 7, 2, 6, 8 is 2 multiplied by, you've got to be careful here. There's something I'm actually not doing here, but it's fine. Divide both sides by 2. What do we have? 1 there. I'm just lazy to get a calculator. If anybody, that will be 3 in 12, 6. And that will be 3, 4. Is that fine? Let's bring in laws of exponents. If you were here in the grade 11 class, I did use logs. And I told you I can use logs for solving. So, those who were here in the grade 11 class, this would not be new to you. I can use laws of exponents as well by changing that into factors. And you can use your calculator to find. Do you guys know how to use your calculators to find factors? Okay, the calculator I have on my screen will not work for me. Shift fact, right? Oh, it's 18. Sorry, 18634. 18. Thank you. 18634. Can somebody use a calculator to find the shift fact there? What's your answer? Yes, Waruna? I hope I didn't.
The sequence use the different number. Because there is 32768 and then here you use 3.
Oh.
Yeah,
Oh, thank you. Thank you, thank you. Thank you. 32768. I wrote 372. Okay, so if we divide by 2, what do we have? 1, that is 16. And that would be 3 in 16, 8, and 4. Is that correct? Let's just confirm that the numbers are correct because it's going to affect our factors. All right. Thank you, Waruna, for that sharp eyes there. Okay, can we find the factors? Somebody help me there. Use your calculator.
2 to the power 14.
2 to the power of 14. Oh, beautiful. So it means 2 to the power n minus 1 is 2 to the power 14. Therefore, n minus 1 is 14. And n would be 15. All right. Anezwa, sorry, we were using the wrong number. I see you gave me the other factors. Are we okay now, guys? What if I want to use logs? And I don't want to use, we need to learn, this is grade 12 now. If you were in the grade 11 class, I taught them how to use logs. When do we use logs? We use logs when we are looking for exponent variables. So I'm going to quickly do that in 2 minutes. How to use logs. Are we done with this page? Okay. Finding exponent variables. In case you missed that class, this is a quick revision. We can use logarithms. A to the power x equals to b. We can find the value of x by saying log of base a and b, where b must be greater than 0. Very crucial. Where b must be greater than 0. So anytime I have to look for an exponent, which is a variable, so if you check this, what was the number? Sorry, I'll go back. 16384. I'm looking for n minus 1. And that n minus 1 is a variable and it's an exponent. So the idea here, please, in case, I know you're seeing this for the first time, that is a base. It will also come here and be a base. So my base is 2. So I'll say n minus 1 equals to log, what is my base? 2, 16384. Please look at your calculator for me and find the log with the 2 boxes. Give me a thumbs up if you found it. The log with the 2 boxes. Press it, and I'm sure you know what to do. The base is 2, 16384. Check, 14. Powerful. This we will use 3 times. We're using it now. We use it in financial maths. We're going to use it in functions again. So take note. Even algebra. So algebra, financial maths, functions, number patterns. And then for physical science, you will use it under acids and bases to find pH, which you did last year when you were looking for pH, negative log of the concentration of the hydronium ions. So we need to quickly get used to this. Guys, are you okay with our introduction into geometric? Let me give you one question to do for me quickly. Consider number 1. Determine the general term, which is Tn. Number 2, determine the value of the 8th term. And number 3, how many terms are in the sequence? 5 minutes. For writing, 40 seconds. And you have 5 minutes. Were you able to walk through? Ratombo, are you okay? I'm just seeing your question now, but are you okay with the use of the logs? Tilidzi, what's wrong? Just type it like that in the way your calculator. Can you unmute yourself and talk to me? What is wrong with the use of logs? Your calculator, yes?
I was asking if the equation is it log B over A?
No.
Because when I put in my calculator, the equation you gave us,
Yes.
the x is equals to log B over A.
It's not over, it's base.
Oh,
That's why your calculator has, there are two logs there, which I explained in the grade 11 class. You would see that. Do you see? It's not over. It's a base. All right. It's a base there. 163. If I want to use over, which I didn't want to bother you with too many of the use of logs, I would come here and say divided. Check. Now I'm using a different log. 163. Do you see this one has no base? Over.
yes.
Log 2. This is another way of doing it. Just to give me 14. All right. But this one is simpler. Let me just put here all. Okay. Are you okay now?
Yes.
All right. This is another way of putting it on your calculator. So you must know the different logs. This is 1 and this is 1. I like the combined one where we just combine the number and its base. So I press my log once. Okay. All right, let's look at this one. Determine the general term. What's your ratio? I think it's 1/2. Do we agree? Is the ratio half? Oh, there's no ratio here. I hope I didn't make a mistake. Oh, guys, I made a mistake. Go. I made a mistake. There's 1 here, and there's 2 there. Oops, I only noticed now. So let's walk through. It's 2, 1, and nobody talked. Nobody raised their hand. Because your ratio must be consistent. 1 divided by 2 is half. Half divided by 1 is half. 1/4 divided by half is also half. So please just check with me next time. It was just an error. So what is my general term? Tn a r to the power n minus 1. What is our a? Our a is 2. And what is our r? 1/2 to the power of n minus 1. Please don't say 2 divide. Please don't do that. Please don't. And that's why I wrote the other one out without multiplying the bases. Please don't. Are you okay with this? If I want, I can use laws of exponent to simplify, and examiners do that sometimes. So an examiner can come and do this, but apply the correct rule of math. So an examiner can come and say 2 times, this is 2 to the power -1, laws of exponent. 2 times, multiply that out, -1 times n, -n and 1. Now, the examiner would say, okay, we are adding this together, laws of exponent. 1 plus 1 minus n. Okay, so an examiner can do that, simplifying using laws of exponents. But preferably, if they don't ask you for any extra thing, just leave it like that. Are we on the same page? Are we on the same page? Let me know. I want to test this formula. 2 into bracket, 1/2. All right, so the power of When my n is 1, the first term, 1 minus 1. Check, it's giving me 2. My second term, n is now 2. So instead of saying n, 2 minus 1, second term, 1. I can check the third term, 1 over 2. Is it making sense? If I check the fourth, it should give me 1 over 8. Do you see that, right? Good. It means I can already answer my next question. The 8th term, my n is now 8. 1 over 64. T8. 1 over 2. 8 minus 1, which is 7. 1 over 64. How many terms are in this sequence? Okay, so I know my Tn is 2 half. We just need to solve 1 over 1024. We simply, okay, I need to go to the next page, otherwise it's going to be clumsy. Are you okay with this page? I want to go to the next page. I don't want my work to be clumsy. All right, is there any question? I saw a thumbs down. Are you busy writing or you have a question? Let's see quickly. Anybody with a question? We just want to go step by step, no rushing. It must be well done. There was somebody who gave me a thumbs down earlier on. Is it still a thumbs down or a thumbs up? Can I move on now? Okay. Everybody good? Just waiting. Okay, so let's move on. 1024. What's our Tn again? All right. So Tn is 2 into 1 over 2 n minus 1. 1 over 1024 rather. How do we do this? I think I can divide both sides by 2. If I divide both sides by 2, this would be 1 over 2048. Do we agree with that? You can use your calculator to confirm. And then what do we do now? We can bring in our laws of exponents, or we can bring in our logs. Now, when it comes to fraction log, I just want us to be very, very careful. All right, I really want us to be careful. I'm going to have some time when we get to functions. No, but I need to do it here. I need to take you through fraction logs. Maybe tomorrow, our next session, I'm going to do some few things on logs. Okay, but for now, it would work. So what is n minus 1? Log, what is my base? Half. No, 2048. Put this in a calculator. What are we getting? Because we need the knowledge of logs very well, you know, when we get to sum. Very, very important. So I have to take my time, probably start with 8 in our next session. But for now, it's just basic, 11. So what is n? N is 12. Thank you, Tegofatu. I can also use my laws of exponents. It will still work. If I'm using laws of exponents, look at what it will be. 1 over 2 n minus 1 is 1 over 2048. This would be 1 over 2 n minus 1, 1 over 2 to the power 11. And this can be written as half n minus 1 half, because 1 to the power 11 is still 1. So n minus 1 is 11, and n would be 12. Are we on the same page, everybody? Okay, I think I have one more activity for you before. Today we are going to end on sum. All right, we're going to end quickly going to do the sum of arithmetic, geometric rather. Oh, we already. Oh, okay. This was where I was supposed to use the screen. Can you try this for me? Yeah, try this for me. I'm sure you should be able to do this. Try. Were we able to walk through this? Were we able to walk through? I didn't see your responses. Okay. Somebody give me an answer to the first one. Unmute yourself quickly. Talk to me.
It's 2 over 3.
2 over 3. Do we agree? They already told us that it's so T2 over T1. Correct. Were you able to get the value of K? K is the third term, right? And what is the third term? A R to the power of 2. What is our A? 3. What is our R? 2 over 3. And what's our answer? 4 over 9, I think. Is it 4 over 9?
4 over 3.
4 over 3. Oh yeah, 4 over 9, and then we have a 3 there, 4 over 3. Because we keep multiplying each by 2 over 3. Are we good, everybody? Same page? And then the last one, calculate the value of n. Okay, so we know our Tn is A. My A is 3, right? My R is 2 over 3. Now that's our general formula. ARN minus 1. Now 128 over 729. Remember, guys, please, errors that people do is they do this. That's wrong, please. That's very, very wrong. Let's divide both sides by 3. What do we have? 128 over, what would this be? 7. Is this correct? If you divide by 3.
Getting 2187.
2187. 3 times 7 is 21. Okay. And this is? Now there are so many ways to do this. You can use laws of exponents. Let's try laws of exponent first. From here, I can actually see that 2 to the power 8, I think. If you use your shift fact, 2 to the power 8 would give me 2 to the power 7 rather. 2 to the power 7 would give me 128. And also 3 to the power 7. So if you use your shift fact and you break those down. So I'll have 2 over 3, everything to the power 7. So I'm using grade 10 and grade 11 knowledge here. N minus 1 equals to 7. N equals to 8. Or N minus 1 equals to the base log of 2 over 3, 128 over 2187. Let's learn to use brackets there. Confirm, will that still give us 7? It must give us 7. 2 over 3. And there we have what? 128 over 2187. Are we on the same page, everybody? Thumbs up. Are we looking good? We're looking good, right? We're looking sharp. Okay, we're not going to run into some. I think I might have 1 or 2 questions more. All right. Everyone should be done. Thank you for sending the picture. Look at this one. Do you want to try this one? An arithmetic and a geometric have the same term, first term 5. The common difference and the ratio have the same value. Ooh la la. The fifth term of the geometry. I think I'm going to be killing you on this one. Let me see if I have something simpler. The geometric term in a geometric series or sequence, the third term is 5p plus 1, and the seventh term. Oh, okay, wait, hold on. Before I give you these two questions, beautiful, beautiful. I see. Let's quickly do something. You're going to try those two questions for me, don't worry. Multiple ratio. Multiple ratio. That is, now, if you remember when we're doing arithmetic sequence, we said multiple difference, where we have more than one difference. What if I have more than one ratio? For example, T1, T2, T3, T4, and T5. Here there's a ratio, remember? There's a ratio. There's a ratio. Between T1 and T4, T5, how many ratios do we have? Now, I want you to remember that these ratios we are multiplying. I hope that makes sense. We multiply by the ratio to get the next one, multiply. So it means we have 4 of them, r to the power 4. What is this telling us? We're going to do something together. Let's try something. If I tell you to solve T10 over T4, let's look at this. Already I can tell you that between the 4th and the 10th one, there are 4 ratios, 6 ratios. But let's see. What is T10? AR to the power 9. I'm sure you remember how we got the 9. N minus 1. All right? What about T4? AR to the power 3. Laws of exponent. Oh, what is 9 minus 3? Oh, don't you see a relationship between the number 6, the number 10, and the number 4? That 10 minus 4 should give me 6. Can we make a conclusion? This one you won't find in textbooks. These are just my own deductions. You won't find them in a textbook, except mine. If you find them in a textbook, someone stole it from here and copied it there. You must tell them you know the owner. Yes, a lot of my work has been flying all over the place. A lot of them. Lots of them. Okay, I hope this makes sense. So we can from here conclude that, look, even if I have T25 over T7, I know it's just good. Okay, let me say over T15. What would this be? R to the power 10. And then I find the 10th root. But also remember that if I have an even number here, my answer will be plus or minus from algebra. If it's a 2, if it's a 4, if it's a 6, if it's an 8, any even number, then my answer will be plus or minus. Okay, I want us to try 2 questions, then you will see if we have enough energy this morning, or we can just start the sequence, the series in our next session. But I want us to try, let me see how many questions we have before we go. Oh, good Lord. We do have, oh no, I see this is a series. Okay, we should have done series here. No, arithmetic. Oh, there's an arithmetic. Okay, guys, let's do 1, 2, 3, 4, 5 questions. Then we will go to geometric series tomorrow. Would that be fine? Because I want this to sink in. I want this to sink in. You want to try this for me? So today I just want us to do lots of questions just to expand our knowledge. Try that. 6 minutes. Read, change into maths, then simplify. First, then simplify. Hi guys. Are you still alive there? I see many people are tired already. Okay, so let's do maybe this question. I'll give you the next 4. You work as homework, okay? Because you need time for some of these questions. But let's see this one. An arithmetic and geometric sequence have the same first term. Okay, arithmetic and geometric sequence, they both have 5 as the first. The common difference and the ratio have the same value. All right, this is going to look interesting. The 5th term of the geometric is 80. Guys, so do you see how I try to break my stuff down? All right. The 5th term of the geometric, T5 of the geo, is 80. Determine the first 3. Okay, let's look at something here. I know my A. Now, let's work with this. T5 of the geometric is AR to the power 4, which is 80. Oh, I think this is quite easy. Do we know A? Yes. 5R to the power, I thought it was going to be difficult. Divide both sides. And in 36. So what is R? The square root, 4th root of 16. And I told you if it's an even. And what's the 4th root of 16? It's plus or minus 2. And that's the value of D as well. That is the value of D as well. Is that making sense? Did that?
So,
Yes?
isn't it the square root of 64 plus minus 4?
Sorry?
I'm saying the square root of. Yes, I made a mistake. I see, not the square root.
Yeah.
I think you know the mindset.
Okay, well, now you said
Okay.
you said the square root instead of the 4th root, right?
Yes, I made that mistake. I see
Okay.
now. Yes.
All right. So now we have 2 answers, 2 possible answers, plus or minus 2. And we are told that D. So if R is equal to D, it's also equal to plus or minus 2. So let's see which one would work. Now both of them would work. Now, so for the arithmetic, our first one is 5. The next one will be 7 and 9. 5. If we use minus 2, 5 minus 2, 3, minus 2, 1. So I think we have 2 options of answers. Either that or that. Let me know if that makes sense. Are we okay? All right, let's take pictures of the next 3 questions or so. And then you can try them while you're resting till you rest. Okay, there we go. The first one, quickly. Just take a picture for me, send on the group. Then we will do the sum in our next session. And then I just want to take it slowly. We're not rushing anywhere. We have enough time with us. Yes. Thank you, Tando. The first one is in, homework. We have the second one in. Take your time, interpret. Oh, the mark allocation. All right, I'll go back and see the mark allocation there. Next one, Tando. So some of them I'm bringing in arithmetic and geometric again for us. So we revise on our own. Next one, And you see, most of them are level 1, level 2, level 1, level 2. So I need us to solidify, and I think that was the last one. So tomorrow we'll then go back to geometric series. We'll look at the proof, we'll look at the use of the formula, the relationship, and then we conclude with sigma notation. That we will do tomorrow. Guys, I hope it's been informative for you. Remember, guys, after this, we will then be going into, I think it's Euclidean geometry, but you will only have access to that once you're part of our weekly classes. This one is just to lead, show you what we do, make sure you are acquainted with how we work, and then we will start our extra classes full-time every week shortly. But this is Number Patterns, Lesson 2. We're able to cover geometric sequence today. Have a lovely day. Thank you, Bonolo. Amen. God bless you too. Goodbye. Goodbye.